Where are you joining from? Please kindly let us know where you're joining from. We want to really recognize you and know where you're joining from. Please put it in the chat box. Put it in the chat box. We want to know where you're joining from. Kindly let us know. Uh, Maybe Lorin, Lagos, UK, US, or wherever you're joining from. Please kindly let us know. Okay, thank you. Adiola Lawa joining from Adrekiti. Thank you. Thank you for joining us. Okay. Please put it in the chat box. We want to know where you're joining us from. Oh, Gloria joining us from Germany. That's very, very good. Thank you. Adiola Adams from Osun State. That's Sylvester from Osun State. Thank you. Thank you. I can see other people joining the call. Please kindly let us know where you're joining from. Ezekiel from Nigeria. Thank you. That's one of our hosts. Deborah from Edo State. Thank you. Eugene joining us from Kenya. Thank you. We want to know those joining us from Africa, those joining us from Germany, US, UK. We want to know where you're joining us from. Please kindly let us know where you're joining us from. Okay. Opeyemi Jamal from Ilorin, Mozambique from South Africa, Linda from Canada. Thank you so much, everyone, for joining us. Please kindly let us know. We have just 2 minutes more for us to do that. We have 2 minutes more. 2 minutes more for us to really, really know where we're joining from. Please kindly let us know where you're joining us from. Uh, Isaac Ajao from Ado-Ekiti, thank you. Thank you for joining us. George Okoro from Abia State, thank you for joining us. Thank you for joining us. Others, please kindly let us know where you're joining from. Please kindly let us know where you're joining from. We want to um, be able to identify where you have connected to the Unilorin R user group. Thank you. Zinat just joined. So Suleiman Aremu just joined. Thank you. Thank you. Thank you. Thank you. Thank you for joining. We want you to kindly put up in the on your status on WhatsApp about the Unilorin R user group. I'm currently attending Unilorin R user group. I'm going to provide the link to I'm going to provide the link to the event where others can also connect with you. You can make your friends to connect with you to really join the event, to connect with us and join the event. Thank you so much, everyone, for joining. So it's 5 minutes already. I also want to recognize that one of our hosts today is also on the call. We want to recognize Dr. Isaac. Are you there? Dr. Isaac, are you on the call?
Yes, I'm here. Thank you.
Oh, thank you so much, Dr. Isaac. We are glad to have you. So this is the Unilorin R user group meetup link. It's already in the chat box. So you can share, you can make a screenshot of this call right now and then put it up. Your friends would also love to connect and join this program. I'm pretty sure that they would love to join this program. Please kindly share with them, and then we would love to also have them on this call. Now, briefly, let me make a brief presentation of this program. This is the second meetup that we shall be having in the Unilorin R user group. What is the Unilorin R user group? Today, our agenda will be to welcome the participants, which we have done. I'll tell you a brief about the R user group. We are going to also give you a brief introduction about the organizers, and then we are going to have the training. The our user group is a dynamic team that have been put together to help beginners, intermediate, and experts in the use of R for data analysis in this fast evolving world. Our mission is to use R in data analytics and data science and to also help in its impactful application across other fields like businesses, in healthcare, also in clinical research. We also want to help people that are experienced professionals, those that are in different fields. This training is not limited to only statistic students or people in people in clinical science who use it for data production. It is also applicable to people in diverse fields of study that want to actually explore the use of R, the use of data analytics
Yes.
beyond just using Excel and every other data analytics software. R has wide application, and that's why we are putting together professionals and those that are just learners or those that just want to have the understanding of the use of R. Our aim is to build a robust community of data science, artificial intelligence, machine learning professionals, and academics. How do we want to do this? We want to collaborate, we want to have mentorship. Seminars like these are part of what we have. We held the last one in November. We want to have trainings, we want to have conferences. We are committed to nurturing talent and driving innovation in this field. We welcome you and encourage you to join us in this world of R together. This program is actually facilitated by the Unilorin R user group, and you must have connected through the meetup. The link to the meetup is what we have. We also have it on the group. This meetup, meetup.com// Unilorin R user group. That is where you'll be able to connect with us and then follow up with information that we are going to provide to the users and those members that will be joining. Currently, we have above 400 users that are joining the R user group. The organizers are myself, Dr. Farambi Samuel. I'm one of the co-hosts. And then our host is Dr. Garuba from University of Ilorin. And then no other person again than Mr. Ezekiel Ogundepo GBG himself, who is also an expert in her. Now, we have made a blend of statistician and professionals. I am a biochemist. I use R in my own field of study, especially for data production, for experimental analysis, assay, drug development, etc. Now, for us, we have professionals in this R user group. We also have those that are using R in the applicable sense of it. So this program is actually being put together by the three of us, Dr. Gariba, Mr. Ezekiel, and I. And we are going to be providing professionals and technocrats to guide us in the use of R. Today, I would be glad to introduce to you our facilitator for today. But let me bring on board Mr. Ezekiel to do that, to introduce and also give a short bio of our facilitator for today, Dr. Isaac. So over to you, Mr. Ezekiel. Right, so let me do the introduction of the speaker myself. Um, Today we have a very, very experienced R user who is going to be taking us in the training of today by name Dr. Isaac Oluwaseyi Ajao. He is a principal lecturer in the Department of Mathematics and Statistics at the Federal Polytechnic Ado-Ekiti, Nigeria. He is an accomplished researcher and educator. He has significantly contributed to statistical analysis, data science, econometrics modeling through his extensive publication record. His work spanned advanced topics such as spline and quantile regression, statistical interference, and data-driven decision making, impact, impacting diverse fields from economics to social sciences. Dr. Ajao is known for his commitment to academic excellence and innovative research. Dr. Ajao also plays a vital role in mentoring future statisticians and data analysts in Nigeria. Ladies and gentlemen, it is my pleasure to bring on board and to introduce to you our facilitator for today, Dr. Isaac Ajao. I think we are going to, yes, thank you so much for giving thumbs up, thumbs up. Thank you for giving the digital thumbs up. Thank you for giving the digital thumbs up. So, Dr. Isaac, I want to hand over to you. Thank you, everyone. I wish I could just mention our names as the thumbs up are coming up. Thank you. Thank you. Dr. Isaac, let me hand over to you, sir.
Thank you, my host. God bless you. And I'm honored for
Thank you.
inviting me. It's as if I'm facing the whole world now. But I don't know how many people that will have joined. I don't know how many people will still join from far and
Oh,
near.
and then now
And
actually
also,
we are 38
yes,
of us here right now, and
okay,
we have people
okay.
representing Europe. Europe is represented. Africa is represented. I have not
Uh-huh.
seen anyone from Asia, but then
From Asia.
we have them all around represented. Thank you.
That's good. Well, I want to welcome us once again. I know the statistical will join us later, and other people, though the link have been sent here and there. Those that are professional statisticians, those are still learning, those that want to be sure of what they are doing, whether it's right or wrong, those that want to see how for the first time, because it's an avenue according to what my host said. This is an avenue for us to, uh, talk about R. A lot of people are afraid of R. A lot of people prefer Python to R, and they are statistician. The fear for R is what is making them to be driven away. So it's an avenue for us to let us know that R is not like that. So I have prepared some slides which I will explain. It's not everything there, but later after the lecture, I'm going to share the code I'm going to use for examples. So I want to encourage us, those that are here, 30 of us, and those that will join us. It's a very good thing that we are here. And I want to encourage us. Anything I'm going to learn from this, let it not just be here. After this training, after this lecture, let's make sure we start using R. Listening to it is good. Doing it is the best. And when you start, you should talk to yourself that you are not going to stop. You don't use it, and later when you now run into problem, you now quickly run back to SPSS and Excel, which may not give you what you really want. That's how we started also. But we are no longer going back to them. Because where we are now, that is where the world is. Everything is now data science, data analytics, and so on. Once again, you are welcome. Let me share my screen. All
Yes,
right,
sir.
that's good. Okay. Thank you very much. So I was saying that statistics, we are bringing everything together now. We say statistics and data analysis. And when you look at it very well, it's very hard to separate the two, data analysis and statistics, or statistics and data analysis. The two go together. And some people were thinking, what about data science? How do we even define statistics? Data science itself is just statistics. And that's why I started, statistics is a science of data. It's science of data. So when we say data science, it's like we are putting statistics forward for people to begin to use. So the underlying definition of data science is statistics. So without statistics, you can't do. There's nothing like a data science. So because science itself is science of data. So that's when you cannot talk about data analysis. If you don't know what statistics is all about, you don't talk about data analysis. So using R now. Before emergence of R, before existence of R, people have been analyzing data. And the analysis we're talking about is just a way of showing to the world or to people that are watching or want to listen to your presentation what your data is all about, either through table or visualizing it. So what we want to do today, we want to see how we make use of R in data analysis. And know if you well that it's not, we are data analysis as rich. It's not just for statistician alone, it's for everybody. So these are things we have to learn in this training today, by the grace of God. These 2 hours, God will help me to be able to do justice to the topic. The topic, once again, is statistics and data analysis using R. This is organized by Unilorin R users. So you also can become part of them. Since you have registered, I think your registration will lead to updates. Anytime you want to do any training like this, you'll be updated appropriately. So introduction to R for statistics and data analysis. I want to cover overview of R and its importance in statistics and data analysis. Then how do we install R and R Studio? Then basic R syntax, the variables, data types, and functions. Then how do we load the essential libraries? How do we load the essential libraries? So we need to put this one there also. The TDVers, ggplot. TDVers itself is a very, it includes so many other packages. If you have it, you are going to have access to ggplot and all the rest. Then core statistical techniques using R. When we say core statistical technique, we are talking from the basic to the complex. The first thing that comes to your mind when you see data, what do? You try to diagnose, to summarize. What I call descriptive statistics here is what some call summary statistics. I can put EDA here. EDA is exploratory data analysis. When you see your data, what do you do first? I'm going to talk about it. What do you do about it? Then when you summarize, these are all this one you see in brackets, they are functions we use. This one comes with the base R. Whether you have installed any library or you have not installed, all this one will work and give us results. Then we now go to data visualization. Some of this data visualization include histogram. When do you use histogram? When do you use box plots? When do we use scatter plots? When do we use ggplot? All of these, they are under visualization. I want to tell you, many people we have in data science today. Hello? Hello?
Yes, we can hear you,
Hear
sir.
you loud and clear.
Okay. Many people we have in data science today. That is, you want to learn R, you want to learn Python, you want to learn this and that. Do you know what they are there for? It's just for data visualization. From my experience, I've seen this because I'm both in class and on the field. I do the two. I lecture, I teach data science, I teach R, I teach Python. You see people that say they want to learn data science today, they hate statistics. But by the time they are learning data science, they still meet is there. And that's where the issue is. You can't just go to data visualization. You want to be plotting pie charts, histogram. At times we meet some of this visualization that people are bringing up. We cannot talk because where they are presenting all these things, it will be as if you want to destroy their work. So we normally tell them to learn it. Training like this, that's why I like this training. And God will give them the grace to continue to propagate this so that people will have knowledge of what we call data analytics, statistics. See, so histogram is not just for any data. Boxplot is not just for any data. Well, I will talk more about it by the time I move forward. After this slide explanation, I will surely go to practical aspects, then we'll do it together. Now, hypothesis testing. See, I call this subsection core statistical techniques using R. Hypothesis testing, generally, after you have described your data, you have virtualized it, you want to go into hypothesis. That is the inferential statistics. You want to make inference. And before you do that, you must set your hypothesis. This one does not follow whether you are in science or engineering or it's everywhere, cut across. You will work, we are working with everybody, with people in law, environmental, that's estate management, quantity surveying, surveying, and you want to build tech, all of them coming to business again, BAM, banking and finance, accountancy, all of them, but they set the hypothesis. Some we have 3, 4, 5 hypotheses, and each of these hypotheses, talking about their aims and objective. And we must be able to state them well. Some will go for t-test, some will go for ANOVA. It depends on the data. Some will go for one sample t-test, some independent t-test, some paired, and so on. Regression analysis now. Some will tell you, you see, okay, I want you to do this for me. I'm doing a PhD. If you're going to do one way or another, I want to use. I used to ask them, are you the one to tell me what to use? What inform you that this is the tool to use in statistics? Yeah. So this is available for us to know when to use what. So simple and linear regression. When do we use it? These are the only one you see in brackets are the code we use to execute all of this. Then data analysis workflow. If you go back to where you register for this training, you see these are already highlighted. So these are the points that we need under data analysis workflow. We need to know how to import our data. This alone has taken so many people away from R. To bring data to R, whether you are using the whether you are using R Studio, you are not using it, to bring it is very, very easy. And we have so many ways of bringing your data, our data to R. And it's just to follow simple rule. I'm going to do this for what you're going to see today. The first thing after you are through with your data, because many of our data are on Excel, either CSV or Excel itself. And you must know that this varies. We have CSV, we have XLSX. We also have XLS. I will show you when we are doing the practical. Now we have data cleaning. Then this rich Excel you see here, all of these they have their own function. CSV, we use it in Bizarre. Anything you can do without importing or without installing any library on R. You want to bring it in, it's called Bizarre. One of them is using read.csv. This is why you're going to install it. Data cleaning now. Data cleaning is the next thing you do after you have imported your data. We are saying data analysis workflow. What do you do first? What do you do next, like that? So data cleaning now. What is data cleaning? You want to undo your missing values. This is very popular function. na.omit. Or at times you want to know how many, which one are omitted. When you know all of them, sum everything, you're going to have it there. Then what do? Are you going to add all the values, the remaining values in that particular column and replace and take the sum? Then after taking the sum, do you want to find the mean and replace the empty values, empty spaces with the corresponding mean or the median? That's what we call data cleaning. Data cleaning can take you a week. It depends on the size of your data. Imagine you are dealing with maybe 500 by 1000 data sets, 500 rows, 1000 columns. We have data like that. So you see down, by the grace of God, today we now have simple code you can write to deal with that. So data transformation. This is very, very important. There's a package we call TDVAS. TDVAS is, I've said it include many other packages. Once you install that, data transformation is very easy. How do you filter? How do you select? How do you mutate? You will see all of this. How do we undo all of this? You want to bring, as when you want to isolate a particular variable in so many other variables on your data. Imagine you have brought it through importing data here. So what are you going to do to it? Are you going to delete it? Do you want to keep it? You want to add another one? These are the ones we use. Then exploratory data analysis, which I mentioned at the beginning, is to summarize and visualize key patterns in that your data. You want to see key patterns. What is the summary of that data? EDA. EDA is very common. EDA is very common. You are exploring it. You want to see the mean. You want to see the median. What is the first percent? What is the 25th percentile? What's the median? That's 50th percentile. What is 75th percentile? Third quartile. Things like that you want to know. EDA will give it to you. Then reward use case. data-driven decision making. Want to now this is where I try to bring up some data, live data. Then I'll go through the process a little bit. To time is not there to go into detail, but we show you how we lay our hands on it, and how we get our results, and how we take our decision. You see, visualization is important, interpretation is also important. We now discuss the insight. Now, I want to go into detail of this. Introduction to R for statistics and data analysis. Said it that R is a very powerful and open source programming language designed primarily for statistical computing and data analysis. It provides rich ecosystem of packages and built-in function for handling, analyzing, visualizing data. R is widely used in academia, research, and industry such as finance, healthcare, and machine learning. By the grace of God, I've used all of this. I've worked with people in industry, people in finance, people in healthcare. In fact, doctors, doctors, many of them prefer using Starter. I realize that. I don't though by the grace of God, I started with Starter also. But there are so many things because of this open source, so powerful. I don't know how many packages we have. I read some yesterday on R. Is it over 18,000? Can you imagine? So it started that direction. So that's why we have to key into this, whether you're a statistician or you are not. So far you are dealing with data, you need R. Hello? Can you see it now?
Yes, please.
Yes, we can see your screen now, sir.
That's good. Sorry. So I was saying that you see, some people, once they have picked a particular software in statistics, that's what they are going to. They are missing a lot because you are talking about R. This is one of leading statistical software. I come to realize again that even R can be used to develop a package. I mean, an app, which I've done. I won't come here to tell you what I've not done before. I've developed app that you can use online. The only thing is that I've not put it on a Play Store, and many of them, I like 3 of them. So R is very, very rich. In fact, if you want to enjoy statistics, go for R. So now I've also used it for machine learning. Machine learning ranging from SVM, SVR, support vector machine, support vector regression, random forest. You want to use it, all of this, they are very, very good using R. I want to use artificial intelligence. The way R will give you the charts, that part, that artificial intelligence, the neural network. Neural network. The way it's going to give you your plots for neural network. I've never seen any software that has given it like that. And this is from what R can give to you. So it's very rich in that. Now, these are importance of R in statistics and data analysis. There are more than these. I'm only giving you these few ones. Statistical modeling. See, R has robust library for regression, hypothesis testing, ANOVA, time series, and Bayesian modeling. You know that we have people here that are on Bayesian. Work, Bayesian, other software cannot go near. The ANOVA, time series analysis. The kind of model you're going to see, that you're going to come up with from this is very, very okay. In fact, at times you are presenting, people that are supposed to assess you, they are the one to tell you later, please give me that, I love it. It's only in R. So data manipulation, packages like DPLYR and TDVAS, those two, I love this. The way they work. Once you have TDVAS, because I told you DPLR has so many under it. It has ggplot, it has DPLR by itself. They are all very good when it comes to data manipulation. You want to add another column, you want to remove, you want to match, you want to filter, you want to summarize. These packages are very, very good for cleaning, for transformation. So data visualization are ggplots. ggplots is very, very good. It's a leading tool for creating high quality visualization. Very, very good. And I don't know any, I've not seen any map or charts graph that this people cannot handle. Very robust and is of high quality. The background, the color. Do you know that when it comes to color, R has more than 600 colors? 600 colors, more than 600. Those of us that are not very good in identifying color, I don't know the difference between red and that's one color that people, women are very good in that. They will say, no, this one is cola, this one is purple. I find it difficult. The only thing you need to know is just remember the English name, put it there, I will bring it, and give you the color. The color will be there. That's power GG plots. So machine learning. Told you machine learning, I've used it severally for people in engineering and people in civil. You want to see, you want to train your machine to be able to predict. R is very good in that. R support machine learning technique via carrots, random forest. These are few of many of the packages that we handle in your machine learning for you on R. Then reproducible research, Koto and R Markdown. These are powerful ones. If you use Koto or Markdown, R Markdown. Markdown is everywhere, but we have R Markdown on its own. Even Python also has Markdown. But R Markdown is different. I will use, by God's grace, time permit, the work I'm going to do during practical aspect, I'm going to run it on script. I also run it on Markdown. You will see. And the one I did on Koto, I'll also show it to you. You see, Koto will give you a very good output. So you can see R is beyond just data analysis. So you can use it to write your notes. You can use it to write a book. One of my brothers here, Mr. Gundebo, that's what he used to produce his book. If you won't know that he's R that he has used and Koto put together. You have used it to build a site, a whole site. I have a site built using this. So you can, it's not just producing data analysis reports. R has gone beyond that. So big data and integration. R can handle large data sets and integrate well with databases. Yes. Python on cloud platforms. Yes. It interacts with all of this very well. You can integrate Python on R R itself. When you have R Studio, I normally run Python code on R Studio. I've done that time with that number. So let me move. So this is fun to download now because you need to know how to download it. So you download, you come here. Hello, are you with me?
Yes, sir, we are with you.
We are with you, sir.
Yes,
Download R here. So how to download R? You just go to this link. So I'm using cloud. So just click on that. If you click on this, this https:/cloud.r, you click on this, it takes you, say allow. If I click allow now, you will see where it's going to take me.
Dr. Isaac, can you allow us go back to that link for the purpose of those that want to download her for the first time? Or you help us copy the link and drop it on the chat box so that others can. Thank you. Very good. So that those that want to download for the first time.
No worries, sir. No worries. Continue.
All right. You are doing it. Okay. Okay. So I think you have seen it. So just if I click on this is where it's going to take you. Can you see? So because I just have embedded that link. Once I click on this, it takes you here. This is where you can download. Download your R here. This is for Linux. This is for Windows. So if I want to download, many of us use Windows. You click here. You click on this download R for Windows. Then you now look for you are doing it for the first time. This is where you're going to download it. And and so on like that. Then after downloading and you have installed, you come back. You see this. The version we have now, I think, is we are now using 4.4.3 for this
GBG,
version.
you are here to drop the link. Can you drop the link? Let's be conscious of those that are joining for the first time. Okay.
Okay.
All right. He has dropped the link now. Can you
Okay.
explain how to install again so that we are
Okay.
sure
Okay.
carrying everybody along
All
at this
right.
time?
So now, assuming I want to install, once you come here, are we following?
Yes, we are following, sir, Prof.
Now, you are using Linux. You know, each of the what do you call this now you are using? I'm using Windows now. Depends on the one you are using. Or if you are using Linux, just click here, download here. This is where you see. And hello.
Yes, we can
Yes,
hear
we
you.
can always we can hear you. Please, if you have some people have they are raising up their hand. We want to know
Okay.
why. Can you just drop in the chat box so that we can follow up? If you raise up your hand and want to speak, there may be interference. So you may just drop it in the chat box. Drop your concern there. We are going to answer you. Thank you.
Okay. Maybe they have question. All right.
Yes.
Okay. So once they download to install her is very easy. Once you have downloaded it, you just install. You don't need since it's free, it's free, and you don't need to it's self-explanatory. And after you have installed it, you are going to have this particular interface. When you have this, if you have this there, let me increase this. So this is version for 2024. Because the one on my system, look at the you're going to have the version. First thing I'm going to see here is R version. The one we use currently now is 4.4.3, I think. Because another one came out before the end of last year. Now, the name for this one is a Race for Your Life. The all other things follow like that. Copyright 2024, R Foundation for Statistical Computing. Then you can see all of this there. The warranty, the introduction to it. Then you see this prompt. This is what we call R console. R console. This is how we started our R. All of us, many of us that are users of R today, this is where we started. It was later we discovered that there's one called R Studio. So this one is an IDE. There's an integrated development environment where you will. So R Studio is an IDE. But before you can have R Studio, you have to install this R GUI. We call this one RGUI. You can see it. Let me increase this for you to see it better. But this, can you see RGUI? So now you need to install this before you can use R Studio. R Studio is more friendly and it has many, things where you can do your work and you see the results by the side. So this is the first thing you are going to install, just like your Python. Before you can say you want to use your VS Code for Python, use it, or you have to install Python itself. So without this, R will not work. Though you can do your work here, but you are limited. So you need another one called R Studio. So let me quickly, this is R Studio. You can see. Now, the first interface you see after installing opening R is called R console, which is here. This is what you are greeted with. And all your commands are workable here. They are working. Once you put this prompt will come up, then you begin to work. Some of them we see. Now, the R console is a command line interface where you can type and execute your R command interactively. It allows you to run scripts, perform calculations, and see immediate output. It doesn't waste time. Though that depends on the task you are bringing on. Imagine you are doing machine learning. See, the time is going to use to process that is going to be longer than the time is going to use to process ordinary summary statistics. So, but generally, it doesn't take time. So I normally advise people to go for a very good laptop with high RAM of 8 gig minimum, 16 gig, 32. We have people that are using 16 gig, 32 gig. So that one will not waste your time. If you want to become a good data scientist, you want to be using, you don't want to be delayed. So the next one is installing RStudio. You want to install RStudio. Because RStudio is where you can enjoy your coding. You want to write your code, you want to run it, I want to see your results by the side. You can see this one has, you can see this, it has this, it has this, it has this. This is where you type your code, your script is run here. Then this is where you have your console. These are the environments where you have your history, everything you have typed here is being stored here. Then look at your files and everything here. Of course, you can change this theme to dark one, which many of us prefer because of our eyesight. When you imagine you stay with your system from morning till evening every day, and the brightness, the dark color will reduce the brightness, that's enter the light that enter your eye. So if you want to download this, click on this. You can see https /posit.co download RStudio desktop. If I click on this, it takes us there. I know whether you are putting it on the chat box. So you accept all cookies. This RStudio.
Dr. Isaac, sir.
Yes.
We do a little survey. We want to be sure that people are following us. Dear participants, please kindly indicate if you have R or RStudio installed on your PC, because by the time you go into the nitty-gritty now, we didn't want people to just be watching you as if you are casting news. So can you please indicate if you have R or RStudio installed? Can you raise up your hand digitally? Okay. 4, 5, 6, 7, 8. 8 hands are raised out of 68, 11, 10, 12, 13, 14, 16, 17, 18, 18, 19. All right. Thank you so much. So we have about 30% of the class having her on their PC. So it's very, very important that we actually be sure that we're carrying our audience along.
It's good.
The answer, I don't know. Okay, now others who have not installed it, can you tell us why in the chat box? Can you tell us why in the chat box? Let's know why. Are you a new user? Are you connecting with your phone? Do you have challenge installing her? What is the challenge you have? Let's know exactly. We want to see that before we move forward, please.
Thank you so much, Dr. Harumbi. So we have a video on downloading RStudio of a thing. So maybe after the meetup, we send the link, because we only have 2 hours for this meetup, and we don't have time to start teaching people how to install and downloading RStudio. Please, Dr. Isaac, can you continue? Thank you so much. This video is being recorded.
Okay.
Easily revisit the video. Thank you.
All right.
Okay. Thanks for that observation. So that we're not just speaking as if we are telling stories. So thank you, because they must use it after this training. They just have to use it. That's what will be beneficial to us and to those that are listening. Thanks for that observation. Now, this is for RStudio. RStudio, I said, is very important. Look at what is written here. Maybe I should go back to where you can see this is the link. Thank you for saying that I'm going to put up a video that will show them where to download, where to install. So at the same time, this is the link. If you click on this, it takes you here. This is where you're going to download your RStudio. But I told you, if you don't have R itself on your system, RStudio will just be there. It can't work. It's used by millions of people weekly. The RStudio, that is integrated development environment is a set of tools built to help you to be more productive with R and C, Python. So you can run the two software packages on, because it's an IDE where you can run your script. That is that. So once we have installed that, you're going to have this, because we call this one RStudio IDE. You can see it's different from this. This is the background on which your RStudio is standing. So you run your script here, and this one you see is the general one, and it has 4 pins. You can see the first one here is source editor, top left, console, bottom left, environment, history. For the source, the source editor is where you type, you're writing your script, you run it. Then the console is that bottom left. Bottom left is here. See, this is the console where you have all those things you have in the first one I showed to you. That's RGUI. Then you have that one here. All your something is here. The script is here. Then you run it by clicking on run. After you have typed, then the environment. This one keep your history just like as if you are using MATLAB. You have it here. If you keep it here and you save, everything will be there forever as long as your RStudio exists in your system. So you can have them here. Then this one contains, this is the last pane. It contains file, plot, packages. You can have a lot of packages here. Then how do you install? Okay, I'm going to go there. I'll explain more on this. You can see files, plots, packages. That is app. You can have your help also. The people that are using starter, you just type app and write whatever thing you want. The same thing with R. R is even easier to use because once you are online, you type whatever thing you want to type under this app. It will see this place. You can see you have file, plot, packages. Let me increase this. You can see you have file, plots, packages, app, viewer, actually anyone. So you can have access to everything you need. Okay. So the next one, so these are basic operations. You need to install the packages. After you have installed your R and RStudio, you need to install packages. Though to install packages, I said we have TDVAS. This TDVAS is very good when it comes to data manipulation and give access to so many things. So once you have stored this is how to install. You type install.packages, TDVAS. For example, you want to install TDVAS. I don't know whether we have Python users here. The way we install here is different from this. We use install.packages. And it has to be in quotes. Then library. You don't have access to any data you have not installed. If you have not installed it and you are writing library here, and you put the name of that particular library package inside, it will not see it. You must have, R will not see it. R will tell you there's no library or package called TDVAS. It will give you an error comment, and that one can destabilize you because what you want to do, you won't be able to do it. So TDVAS, and once you have installed this, you are now good to go. So the library you see here is to call. You want to bring to limelight what you have installed. You are telling her that okay, that package I installed, bring it, I want to use it. That's the meaning of that library. It's part of the library we have. So for example, look at this basic operation. You have X equals this C you see here is what you use to bring all this data together. 10, 20, 30, 40, 50. You want to do something about this. This is the basic operation. We are starting from in beginning. You have not imported any data you want to pick. That's why I call it basic operation. Imagine you have a data set 10, 20, 30, 40, 50, and you want to get the mean of this data. What you need here, even without installing TDVAS, I only put this one for you to know that, to show to you how to install. Without TDVAS, you'll be able to perform your mean because you have assigned, it's either you use this or you use ordinary equality sign. If you want to get this sign, you see here, this is how to assign. You are assigning this to X. So now you want to type this on your system. And imagine you are your art student, you want to type this, you want to have this sign here. You just put your hand on your Alt key plus minus. It will give you this. But if you are in haste, you don't want to be using this, you can use equalities and ordinary equalities and we give you this. We give the same thing. And once you enter this and you want to get the mean of this, you just type mean. Mean come with R. So once you put your mean and you write your mean outside and put the name of your variable here, it gives you the mean value of this. The same thing is standard deviation. Same thing is variance. Variance just VAR will give you standard deviation. I mean variance. This for standard deviation. And they don't want to worry themselves. What they normally do is just squaring whatever value they give from standard deviation. Of course, to get your variance from standard deviation is just square this. Then summary statistics will give you everything I'm talking about. If I say summary X, it will give me the sum, I mean the mean, the percentiles, and the number of observation. It will give everything to me. Okay. Now look at this. We are going to call statistical technique using R now. I mentioned, I said something about this when we started. Now, for example, you have this student score, which contain student names, test score, and study hours. We should know that though it's not always like that, but that is normal thing. That study hours predict score. Ade has 85 in his score, maybe in star 114. Chooks has 78. Bayo has this. So to Afusat. Then these are the study hours. It's expected that study hours we have correlation with this. We have relationship with this. Meaning that the response variable is this. Score depend on study hours. When your score depend on your study hours, there are so many other things. I'm just giving you this one for example. It's not that it may not be applicable in real life situation. Study hours is expected to determine what our score in a particular course will be. Hello?
We can hear you,
Hello?
sir. We can hear you.
So it's expected that one of the independent variables should be study hours. You can't imagine somebody that's go to school, to class, spending 1 hour and come back to sleep and to do a lot of things to have A. But some people, it depends on the way you assimilate and some other things. So I'm just using for example. Now, this is the data you have. Assuming you want to work on this. Now you have loaded the data. If that data that I showed to you now is on Excel, you want to bring it to R. What do? You now go and import it. I'm going to show it to you by the time we get to practical now. This one is just to give you a general one. Now you load it and bring it. And once you have brought it, that is when you now have access to it. The summary I put there the other time, this summary, you have this summary. This summary you see here is what you are going to write when you are doing the analysis. This is the R script for that data. Descriptive statistics. In this, I'm performing like 3 analysis. You have descriptive statistics will give you the mean and the quartiles. 25th percentile, 50th percentile, 75th percentile, and so on. Now, the histogram. Now, before you can use histogram, your data must be continuous data. You don't use categorical data. What are categorical data? What are continuous data? Data like this, let me show to you. This data is continuous. These are continuous data. Categorical data, they are numbers, they are numeric, which are measurable. You can measure your score. Of course, you can measure your study hours. Categorical are just by grouping categories. How many categories? If I have this now, without this, if I remove study hour from this, and I have name and score alone, I won't even have, I will not put score here. I will not put score here. I may put another thing. I may remove, I may even allow the score to be if I want to describe this, I want to describe this. I cannot get anything mean here because they all occur one time. I did ask it. If I will not, I can just leave it like this and represent, using visualization like a bar chart. It will be treated. Understand? But most time, this one be frequency. I'm not put score here. Frequency, maybe a day has how many times something hours per week, things like this. This one work for 78 hours per month. I mean per month. If this one is number of hours per month that we are working. So most time you are going to have frequency here. Number of counts, you want to have counts here. That become categorical data. So now in this case, because if you don't know that, you'll be using wrong tool, you see, for data set in analysis. And that one will pose problem. So the next thing here is to run histogram or score. Now you have this, you call this one aesthetic. The ggplot is here. ggplot will not work until you have installed ggplot, and the library to use is ggplot2. Is a library, is a package which you have stored. If you don't install it, this will not work. So by the time we get to practical, I'll show it to you. See it. Then the score is what we are picking as your X. The geohistogram here showing the bandwidth equal by field blue, color all of them. They know they have the bandwidth you see here is the size of the bars. We have bars in histogram. This one is telling you the size, the width of the size. The field equals blue. You see here, this field equals blue. Is the color of the inside that you want to work. I mean, the bar you are working with, the bar that you show on the histogram. So the inside, what you want to fill it with is blue. Now the general one will be black. So now the hypothesis, t-test. See, when we say t-test has three type. We have a one sample t-test. For example, okay, let me show you something. Look at this data now. Look at this data. Assuming this score now, it's assumed that the mean score here is 75. If I say, somebody can just come out and say the mean score in that star 114, when I administer that test on them, the mean score cannot be mapped at both, or it's just 75. It's 75. So that's an hypothesis, that's an assumption. That's your claim, is 75. So you now use, because it's one sample you are dealing with, so you are going to use one sample t-test. This hypothesis. So how do you state your hypothesis here? I whether you still remember whether you are new to this or you are not new. If you are new to it, you need to state your hypothesis. You need to state, we call it hypothesis statement. We have the null hypothesis, we have alternative hypothesis. The null hypothesis is hypothesis of no difference, or hypothesis of no effect. No difference when you are comparing mean. No effect when you are in relationship. Hello? Are we all there?
Yes, we are there.
We are following. Thank you.
So, sorry, I want to be confirming whether there's any issue. Now, I was talking about type of t-test we have. Some people just come to here and say, "Hey, Ajao, I want this is my data. I want to use t-test." And this, by the time you look at it, you know that this data is not something so complex. Ordinarily, one sample t-test will do it. Somebody is bringing one column data to you. That's one variable, and it's telling you, "Hey, we have been told to go and use independent t-test, and we want to go and use peer t-test." Look at it very well. It's one sample, and look at the game. It's not that you have carried out an experiment on that particular variable that you have before and after. That what you do in the hospital. I have to talk about this because these are the issues because we expect that after this training, you go and sit down and begin to use R for analysis. But before you use R, you must have all this understanding. How do you use your data for analysis? Now, once you have a single variable data, and you look at the aim objective, the objective of the work, the analysis, you will look at it very well. Maybe the person just want to confirm, establish the fact that mean is this. The average yield of this of maize on this farm by year is 500 kg, and it doesn't have more than that particular value, and it's just no two plots, it's just a plot. In that case, you don't need ANOVA, you only need t-test. So you now say mu, assuming I claim that the mean score for that sample I'm using is 75. You know, whether you are in statistics or not, you normally use mu. Mu is one of the Greek letters. Greek letter contain 25. I mean, Greek alphabet contain 25 letters, just like English has 26. I think Greek has 25 also. One of the letters is mu. Anytime you see mu in statistics, we are referring to the population mean. So now you have established that, or you are claiming that it's 75. 75 is the average score in that class. You now put it here. Mu equals 75. Those of us that have had 1 or 2 lectures in statistics before, you know this formula, what formula look like. You are going to remove your mean from each of your x. You now divide by standard error. But in this case, you are not writing the formula. Everything is here. So now, t-test, you can see the way I put it. T.test. Student, $ score. What am I trying to do here? Let me go back. Look at this student. You know, this student is data set. This student is the data set. So now, and it's contained, this is student data. And it's contained score, study hour, name. You're not using this. So to isolate this variable score from this data set, in this data frame, you need to use $ to isolate it. Though it's not the only method. There is another way you can do it. I can use attach and some other things that we just write score alone. But this is the simplest method to bring it. Because if you just write score here, R will not see it. Because this is the parent name of the data, students. And score is just one of the children. Sorry for using that language. One of the variables there. So you cannot separate your score from the parent data set without using this particular sign, $ to now bring it out. Then you put mu here. Once you enter this in R, to give you the results. If you now compare, then you see the result at the particular level of significance. So the next test here, we have done summary statistics, we have done the histogram, though we have not seen the result, you will see the result later. You see linear regression, study hours versus score. You can see this. You want to test, here we are comparing means. You are saying that the mean is 75. You want to confirm that. Now, here, you want to see whether there's a relationship between score and study hour. I told you, score depends on study hour. Now, look at what I put here. Data equals student. This data is a function. R is expecting you to bring it here, to put the name of your data here. And the name of data is student. You know it's a matrix, it's a data frame. So if you don't put data equals student here, R will not see it. So you now summarize this model. This model, this is what you call, the LM you see here is linear model. You call this one linear model. Score is, and you don't go and write, you have to write it the way it's written in that table. You look at it very well. And where do you see this? We say score, you regress, you study hour. So how do you now do this? How do you get this sign? This sign that look like approximation is on the left, the upper side of your system. the when you look at your keyboard, is located, most of them are located on so many systems. When you look at your system very well, when you look at the upper left side of your keyboard, you see it there. That's where you see this sign. We use it to do regression. Then R doesn't respect any space here. You can see I put my own space here. It's just to make to make it look nice. I may close these spaces. R will still give me results. Then you summarize. Summarize to give you detail of your results. Now, that is another example. We are talking about the workflow. The example I'm giving you here is about is on another side. This one is sales data, which can be used for people in economics. Whether we have them here, you want to do time series, or you are into sales. Econometrics, many of their work they use economic data that has to do with time series, where they be looking for doing masculinity, doing you want to build models like a demand model, so many like that. But in this case, you have categories. Dates, you have sales, we have category. So these are dates where all these sales are made. These are the categories, things that you sold on 24th, on 1st of January 2024. You have these sales. These are in millions, and then put it there. These are the category of things you sell where you got this 500, this sales there. This one is electronics, clothing, electronics, like that. So it's the data. Look at the way I'm going to use it. Now, we got that data. I say load data set. You load the data set. So this is the sales data. You can see you have brought it. Now you convert date. If you don't convert, R will not respond to it. And without time, what I mean by time, daily, monthly, that's time in time series. If you don't convert to date format, it will be a problem. By the time you run the you do the visualization, that's time plot. Your people that are looking at your work, that are watching it, or maybe for assessing or something that I'm doing like this, they won't understand what you are giving. So you have to change the format of the date. So you convert it. As.date is the function we use. As.date. So you now put the date you have created, you now put it inside. You can see date. You can see date is part of the data. It says $date, comma, format. The format you're going to follow is year, month, day. That's the format you want to use. So now, summary, sales. To summarize, that sales for you. See it when we get there now. Now, what you want to do again, maybe you want to now filter sales. This data is different from the other data that contain score and study hour. This one has sales, it has date, it has categories. So what do we now do? Look at the data very well. That data is not for regression, it's not for all those things we did here. So it look like time series, and that's what I'm working at here. Now, look at it. I want to filter sales for electronics only. No, we have sales. Hello?
We can hear you, bro.
Okay. So
We are following.
Okay.
Hello,
Now we have yes, sir.
please, when we cannot hear you, we'll inform you. Please, thank you so much.
Okay, you cannot hear me.
I'm saying that whenever we cannot hear you, we are going to inform you.
We'll get to inform
Okay,
you.
okay.
Yes.
Okay,
Yes.
okay, better. So I don't need to be asking. Now, we have this electronics. We want to filter this. This filter you see here is a function under the TDVAS package. And it has a special function again, a package. We call that package DPLYR. By God's grace, the next thing after this, that is practical, you will see it. You have to install it. If you don't install it, filter will not work, because once you have installed your R, it doesn't come with it automatically. You have to install it. It's a package. That is when you can enjoy your data manipulation. Look at sales that I put here. Sales is the name of the data. This data. I call it sales. Now, you want to now, play around, you want to work with it. This filter, what it's going to do is that it will isolate category. To isolate category. Can you see? I'm interested in this category. And this category has categories. Again, it has electronics, it has clothing. Just two. You can more than that. Now, category, you can see you are assigning this one. What I'm doing here now, I want to filter electronics alone. See, electronics will be somewhere, and the other one also will be somewhere. Electronics will be there, clothing will be there. It will give me summary. How many of them? What is the sales, total sales we have? Because you can see electronics is 500 here, $500,000. 800 here. Here we have 650. It will now put them together. So now this one will give it to you. It will filter it for you. Then you want to aggregate total sales by category. You want to aggregate, you want to bring them together. There's disaggregation, there's aggregation. Aggregation means you put together. And disaggregation means you are breaking. You understand? So you want to now group. What I put here, I put sales here. I said total, when you aggregate, it means you want to get total sales. Total sales. This one is not revealing total sales. Is individual sales from each of the category. The one I'm doing here now, we bring the sales, total sales together by category. You can see, let me explain by one after the other. You see, sales is the name of the data. You can see. Now, what you see here, we call this one pipe. This one is from your library that you have used, which is your T device you have installed. I say you must also install your DPLYR. I will show it to you the next. I'm just showing this for you. By the time you see it, so you'll not be surprised. After you have installed that is when this one will work. What this one does is that we use it, instead of giving ourselves problem by writing line by line, you have brought the sales data here, and you are telling R that he should help you group that data by category. See, you want to group this data by category. We now be having how many categories? We have only 2 categories: electronic and clothing. That's what it means. Very. So it happens like that. If you have scores of students in the class, and you want to see, people that are from Ondo State, maybe you only have Ondo, Ekiti, Kwara in a particular class. You want to see their scores, or score will not work in this case. Okay, let's continue to use score. You want to see their scores differently. It's possible, then you can bring them together using this category. Category we sort. We look for people everywhere that are in that category within seconds. Those packages are very, very important. So we bring it together, the category, then you use pipe again to continue. Summarize. You want to summarize that sales. You want to summarize the sales together. It will give you, because we're talking about aggregate total sales. Can you see? And I call it total sales. So all the sales from the 2 categories, that is electronics and what the name of the other one, and clothing, it will give us the total, which is not in the original data. So this one we do it. You now say total equals sum sales. Sum is a function. Sum means add all the sales together. Then print total sales. Well, I say this print total sales, you may not put print. You can just write total sales. It will give you the total. But it's a good culture when you are writing your code to put print. So now it's going to give it to you. Now, the next thing is to plot your time series. I'm going to see the next one I'm going to do. Now, real world use case, data-driven decision. Going to the end of this before I now move to the practical aspect. Now, predict, for example, I want to predict employee performance based on hours. Employee performance based on their work hour.
We are not hearing you.
Okay. Hello. Hello.
Hello.
Hello.
We can hear you.
You can hear me?
Hear you,
okay. Okay. Now, I say I have a data here. This data is about employee performance. Employee performance. And we have work hour, we have performance score. So we have this work hour as all these values. These are number of hours, these are performance score. Well, it's expected that there should be a relationship because work hour and the number of hours you are spending and your performance score. So we are saying that your performance score will depend on your work hour. Yes, that's how it's supposed to be. The number of hours you are spending in working, whether you are on your own, somebody is committing 40 hours and is having performance score of 85. Somebody is committing 45 hours and you are having 90. I can even change one to the income you are having at the end of the month or wage. You see, this could be wages also because what is determining it is work hour. Whether you are working for yourself or you're working for somebody or government. So we want to test. Now, what do we do? So you load the data set. Then you want to talk about scatter plots. Scatter plots, what scatter plots does, before you even talk of scatter plots, the time you are spending on your data is not that you are wasting it. It's not wasted. Studying it. Already you study data, okay, working hour, study hour, okay, work hour and performance. There should be a relationship. And the simplest plot of visualization you can come up with that will give you a clue on that is scatter plots. You have not done regression, no. You only want to see, are they related at all? You now use ggplots. ggplots, performance. You can see, you have performance there. Performance, this is performance. This is the name of the data. Performance, then you put your work hour as your x-axis. Your y-axis because is your response variable. X is independent. Y is dependent. So people some people call it response variable. Y calls what they call X predictors, telling us that your performance depend on work hour. So if we are to be rated, they look at your work hours. Then the geo point, we give the points, the connecting points there. Then this geosmooth will tell us, it shows what you want to use. We have LM here. LM is linear method. So, linear model, which talking about what your data will look like. It will perform the regression analysis and put the line of best fit there. That's the method you are using. We have spline. We have some that we have quadratic. We have the one that is even more than just quadratic, raised to power 3. We have cubic. A lot of them, but linear model is the least. So we have linear regression model now. Now, if you have done this, you can't stop here. Scatter plot is not the end of when you are doing analysis, just to show whether there's relationship or not. You are just visualizing. So the real model is the linear regression model. You can give this model in any name, but I want to, my own practice when it comes to modeling is, I want to write my code, I normally use what is peculiar or what is related to what I'm doing. I'm talking about performance. So I say perform _ model. It's not just writing model. Some people can use another one. They can use model 1, model 2, but it's just my own style. Now, linear model, see, performance score, because performance score is the name of your response variable. Look at it. Why? Look at the way it's written. You must not change anything there because that's what the way you have declared it here. See, anything outside that R will not see it. And I hate seeing error message. When you are seeing error messages, you will be there, you will be discouraged. So it's better you do it right from the beginning. So performance score regress on work hour, comma, data performance. I told you there's another way you can use without writing this data. You can just write attach here in brackets, you put the name of this, you don't need to write this data here. Then you summarize. Somebody will give you detail of the model. Then you can write out the equation. If you want to write it. Then you can do predictions or other things. Then you can predict. You can see. Predict performance for a new employee working 42 hours. For example, we don't have 42 hours here. 42 hours, not 42. But we have 40, we have 45. So we want to predict performance of a worker. Somebody that's worked for 42 hours. So how do you do that? Normally to do that in statistics, after you have gotten your model from this place, you just say performance score equals A plus BX. That's our regression. Already you have seen your A, that's intercept. You have seen your B, which is your regression estimate or the slope. You only need to put your 42 in your where you have your work hours. Then you calculate it to give you the results. But we have gone beyond that. That's why you are using R. You just go there, write it this way. There are so many other ways through which you can achieve this, but this is the simplest, one of the simplest way to achieve a predicted value. See, work hours 42, data frame. The data frame, you must claim, you are creating another data frame apart from data frame that you have here. That's why I call it new data. New data. So my new data, what data frame does is to create a table. You are creating a table here. You now call it work hour equals 42. Then you now predict. What this one does is that you go to create a table, and we now put this new data I have created now. You are putting it here. The reason why you have to create this is because it does not exist before. 42 is not there. You are the one bringing it. So to now predict, this is why anything you see in blue like this, they are function. Predict is the word, is the code you are going to use to get your predicted value for performance at 42 hours. What will be the performance of that particular worker if he work for 42 hours? Because it's not in the table. And that is the beauty of any model. When you have a model and you have come up with the model, you have done so much work. It's not just having model that matters, but prediction. The prediction is very, very important. Anything you are predicting must not be too far away from the observed, from the real values on ground. So once you have saved the data sets, you can load them using this. All of the data we have used. I use three data now. How do you now save them? How do you load them? Of course, I've shown this before. Just a read.csv. If it saves, you'll read this, and all of this will come to your R for analysis. So now the next thing is to go to hands-on practical session. It's time to apply this, using all of the R and the R Studio. We explore real-world data practice key concepts, following along the guidance and running the code ourselves. Feel free to ask questions. So let's now go into practical session. Thank you. So I want to go to practical session now. Okay.
Hi, Dr. Isaac.
Yes, sir.
Thank you very much, sir. I don't know if we have questions from the attendees. Is there any question before we move to the practical session? Thank you. Oh, okay. Is there any question, please? You can just raise your hand by using the hand logo. Okay, if there's none, okay. Dr. Isaac, thanks so much. Please continue.
All right, thank you. So we are now at the practical session. So see this practical session, I'm going to use the script, that's R script, and I'm going to use R markdown. Let me quickly take you through. Look at file. Assuming I want to use the way I have my already written, those things I show you on the slide, they are here. And here, this is where we write. This is where we write our code, our script. And look at the file extension for it. Unilorin training script.r. This same code here. I've already written them again. All this line of code, they are also in R Markdown. This R Markdown. This one has title, author, date, output, and see the way they are written. See the way. So they are the same thing, but I show you the difference by the time we are through with this. So now this is the general one for a beginner that's just learning how. Once you open, if you still remember, I show you this. RStudio is a very, very important when it comes to programming. This is where you can enjoy your programming. We say R programming. This is where we do our programming. Maybe I should even introduce RStudio itself. Okay, a little bit. We say RStudio is an IDE. What's an IDE? IDE is integrated development environment, where you write, where you develop app. Yes, I want to put this down. People, thousands of people all over the world are using IDE, ranging from VS Code to PyCharm to even Notepad. You're surprised. Notepad to this one, RStudio, and many other. Some they don't anything, they cannot use anything apart from VS Code. But if you are a statistician or you want to be using R, I advise you use RStudio. Very, very interactive and very, very good. Now look at it. You come here to open this. You just come here. As we want to open our new file, you see R scripts. This is what you can see on title 1. And look at the logo R. So you can type anything you want to type here. Once you type it, after you have finished typing it, maybe for example now you want to open a particular data. Maybe I should open just one data.
I can't see your screen.
I want to open data here. Run it. See so many data that come with R. You have not installed any package. These are data that come with your R. See, and we can use any of them. So this is on this script. Then you can pick any of them and open. Come here. This data give you that. See, car data now. There's data called car. Cars. Okay. Then run it. See car data, which you can use for practice. Speed and distance. Let me give you one more before we go to our own. Women. There's so many of them. There are many women. It's even suggesting. You can see power of RStudio now. Because I finished writing with women, it's already giving me option, suggesting for me. You can see, which you cannot see. You can see average height and weight for American women. This data set gives the average height and weight for American women age 30 to 39. See, even telling you even number of things you have there. So and many of them like that. If you want to explore that, just type your data and run. You're having many of these data. You can see so many of them. Now, by the time you now install your packages again, other one will join. So let me close that. Now I'm not saving. Don't save. So I now come here. Let me see. So yes. Now I say install. No, you have to you can see all this hash. Anywhere you see hash, we call it comments. I put comments in front of all this. If I remove these comments now, you will see what you have. You can see the colors change. These are comments. Now, this is why I comment. Now, what's the use of this hash? And what do we mean by comment? Commenting means you only show, you want to instruct, like I'm giving you training now. Now I want to instruct you, I want to let you know, giving information about what I'm going to do next. Say install and load essential library. I put hash in front. That hash is not for you alone, it's also for R. When R sees this hash, R will understand that it should not execute that command. You understand? So if you are, that's why you can see the color has changed. Now it's now fade. It will not run it. So the reason why I'm commenting it is because already I'm supposed to just comment the first one. I should not comment this because I need to install CDVAS. But I don't need to install because I've already installed it. You understand? So, but if I want to install it, let me show you how it will run. You just come here and run. All works is as you can start. One work to be updated, currently loaded. Well, I already have it. So let me not disturb myself. So it will not be installed. Now, this one method, you just write install.packages in bracket. Already I've explained this, the first aspect. So after we have installed it, this is one way of installing. You can also come here, come to tools, see install packages. You can see. You can now the package you want to install. Type it here. See the verse. Can see? You can see it here. When I say install it, continue to once you have internet, continue to install it. And one beautiful thing about this packages is that once you have installed any of them, you have installed them like that, unless you want to update. You are not installing a package twice. So it's just once and for all. Now, if you have installed it, you have to put hash there. Now, for you to use any package, you have to write library in front of it. So after we have done, I've explained all of this. So let me just run this. Run. You select like this and run. See the results. Let me go over. See. This is what I click and see everything. Let me move this one up a little bit for you to see. Maybe I should increase this. Okay. See the mean of your x. The mean of your x here, the mean of this x is 30. The median, the standard deviation is 15.8 per hour. Now, look at the summary. Summary, output of this summary is what you have here. That's the minimum, the maximum, which is true. Minimum is 30, maximum is 50. If it's 1,000, by the time I'm going to import data for you to see how do we deal with imported data. Then it will run it exactly like this. Summary. Now, standard deviation is 15.8. 113. So this is first quartile, second quartile. This is median, this is the mean. So let me move because of time. So the next one here is create students data score. If you remember what I explained when I was explaining the slide, remember this score. This students scores data set. So I created this my own, and I want to print this one now. To print this, all you need to do is just let me reduce the size of this. So you just select. Want to select? Just select the code. Then you run here. When you run, invalid something. Maybe I've added something that is not supposed to be there. So run it. Yes. Now, what did I do there? You can see student score, data frame. Data frame is just to give you a table. Anywhere you see data frame, is to give you are creating a table. And you are saying name is equal to this, score is equal to this. You can see the last one, no comma. After the first one, there's a comma. After the first variable, there's a comma. Second one, there's a comma. The last one, you won't put a table. It's as if you are writing a conditional statement also. When we are writing function. The last one, you don't need to put a comma. Then you close the bracket. You can see the bracket open here and it's closed here. Every bracket must be closed. There are times you have 3 brackets here closing. It means you have open 3 here. If it's 7 that's open here, 7 must be closed here. Otherwise, how do we complain? So then you want to print. That's when I put the print and look at the score. So the next one here is about the student score. I want to do the analysis, which I explained here. I've explained this there. I only want to run it here. I've explained all of this on the when I was explaining the slide. So I want to now run it. I can run one by one. So I'm saying here that this student score, I want to now give it another name. I call it students alone. Students. I don't want to be writing student scores. I call the data, this data, I call it now, this data you see here. And now to assign students to it. How do I assign that? I run this. Run. The reason why you don't see anything is because I've not said you should print it. If I say print students. But once you run a line of code, and now it's not talking, it's not giving anything, it means it's correct. Run it, you can see that's giving me the code. I change it from student score to students. That's giving it to me. Now I want to describe it. Just summarize the students. You can see it has given it to me. Look at it. Look at the summary. The name length is 5. We have 5 rows, 5 people. The class is character. Why? Because they're talking about names. They are not numbers. Then score. You can see score is giving us minimum, maximum, first quartile, everything. If you have 40 variables under student, this is how it's going to give you the summary. Minimum for study hour up to maximum, and the mean on each of them, like that. That's how it goes. Let me draw this one down a little bit. Now for histogram, now look at the histogram. The histogram, which I've explained here, look at what I'm talking about color. The color here is blue. All of them have their number. I told you color has, R has more than 600 colors. How do we know that? We can test. Say colors. Colors. I think it's colors. Yes, it's American English. Yeah. Colors, enter. See, we have 655, 660, 656, 657 colors on her for now. I don't know whether it has increased. You can see white smoke, yellow, green, all of them. And they are alphabetically arranged. So if you are looking for colors, just come to her. White, at least blue, all of this. I don't even know until I put the name here. That is when I know primary colors anyway. The primary colors, just put the color there. If you know the corresponding number of that particular color, you can put it there. So here you are putting black. You can see black is black here. The blue is blue. That's one thing with ggplot. We are using ggplot. So for you to enjoy ggplot, you must install it using this. Install those packages, ggplot2. Put it inside. It's working for me because I said library ggplot2. And before I can use this library, I must have installed it before. So now let me run it for you to see what I'm talking about. See, this is histogram. The reason why this one doesn't look is not more than this because I'm using how many values? Just 5 values. You don't expect anything bigger than this. So by the time I move to the one that I'm going to import, you will see the beauty of what I'm talking about. It's going to form something better. Now, here we have you can see the blue is the field. The black you see here are the boundaries. The boundaries of each of the bars. You can see it's the black.
You cannot see your screen again, sir. Okay, I can see it now. It has come now.
Okay.
It has come now.
Okay.
We can see the screen. We can see the screen.
Okay. Now the next thing here is the t-test. You can see t-test, hypothesis test. On the one that I told you the other, I don't want to be repeating it. I've said it while explaining the slides. The t-test now, that's one sample t-test. One sample t-test. You want to run this. No, the aim here is to test if the average score is 75. If it's significantly different from 75. Now run it. You will see the result. You're going to compare with look at it. This is it. Let me draw this one up a little bit again. See, one sample t-test. Data is students can see is score that you want to see. I've explained how. Then T is 1.996. Degree of freedom is 4. P-value is 0.121. What are you going to now? Let me explain this. The alternative hypothesis is true mean is not equal to 75. I'm not the one that wrote this, so it's R that's writing this one for you. 95% confidence interval, 72.02138, 92.37. This is confidence interval. The sample estimate of X, which is your student score, is 82.2. So this one is, so the claim for this person, what are we going to say about it? Here, are we rejecting H naught or we do not? P value is 0.121. Now, to reject H naught, you need to know the division rule. The usual rule say reject H naught, which is null hypothesis, if your p-value is less than level of significance. Level of significance, the one we normally use, that default is 0.05. This one is greater than it. So in this case, you do not reject the H naught. Do not reject the H naught. So in this case, you go for alternative hypothesis because you go for the true hypothesis, not the hypothesis that say the true mean is equal to 75. You go for it because you do not reject it. P-value is greater than it here. So you go for what the claim is. Though the mean of this is 82.2. So, but you do not reject it. You don't have sufficient reason to reject it because of this p-value. That is it. So we now move again to linear regression. Linear regression, because the data is not much, so I'm just trying to show us, even using the few, you can't use the kind of data, it's too small, but just for training sake, and to show to you that you can actually generate your own data. So the one you're going to be dealing with is more than that. It's data that will be on Excel, which I'm going to do the next things to do that now. Linear regression, run this, you're going to have the result immediately. This is the result, you can see. So your study hour, okay. Does your study hour affect score? And you see, now you have this. See the results. Study hour is 3.3879. The intercept is 50.35. Now look at it. Highly significant. That's one powerful thing again about using R. Look at it. This star, the number of stars you see here, talking about how significant your model is. You can see this one is 0.000384. SPSS will not give you anything like this. Once it's more than 3, I think it's usually 3 decimal places. Anything you want to write. After 3, SPSS will just write 0 there for you. But look at what R is giving you. It's writing everything, details. Then the star you see here is telling you how significant. If it's just 1 star you see, it means it's significant. If it's 2 star, highly significant, and so on like that. See, the 2 of them are significant. Even the intercept is significant. The study hour telling you how do you now interpret this. To interpret this, you just say that study hour is significant to what student score will be. Otherwise, you say that you do not reject H naught. What does H naught say in this one? H naught say study hour and scores are not related. Or you say H naught is that beta high is equal to 0. When your beta is equal to 0, it means there's no relationship. So you reject it because this one is far less than your p-value. That's all. Then look at R square. R square is 99.07. I just said it's also 98.7. General p-value is 0.00. This is core of analysis. If you cannot interpret, you need to work on it. And that's what I'm doing now. See, 99.7, 0.7 means you are saying, 0.9907 means you are saying that your model can explain 99% variation in your response variable, which is your score. Your model can explain 99.07 variation in the response variable. That's very good. If your model cannot explain 90-something%, there's a problem. Or once a little bit above 0.6 anyway, it's okay. But anything below, you will say your data is not adequate. It's not mean your model is not reliable. Things like that. So let's move. Time. Okay. Look at this. Now I've generated data. Data I generated here. You know the one I use here, they are just 5 points. Just 5 rows. I have data that's up to 1,000 rows. How do you import it? You just say, your data must be in your current directory. I normally tell my students, let everything you want to work on, the data you want to use, be in the current directory. Let it be that. What do you mean by directory? Just a folder. Just create a folder and put everything you need. Your data, your anything, even you want to use picture. let it be in that's your directory. If you don't put in a directory, you'll be using paths, whatever path. If your data is on, for example, on desktop, and you want to use it in hard, you'll be using link slash desktop slash all those things. It's confusing at times. So now when you have done that, that's why I'm able to open my own class. Let me open my file for you. You see this, the student score, Nigeria underscore 1000. You will see it here. This is non-user training. See, the students something. And see student score, can see it. It's here. So now to read it, you don't say because it's here, you now double click it, you now appear. It will not appear here. You have to read it. Read.csv. Now that is it. It's coming here. Now I want to check, and if you want me to open that, I can open what you want to see it here. Let me do something. I want to open it here for you to see. Just students. You may put print, you may not put print. I'm not going to put print. So I'm going to run the two. You bring the data here now. See the data. This data. See. Now look at it from the. I want us to see it from the beginning.
Hello, please. Can you showcase where we can locate the working directory? I think it's very pertinent for you to evidence that,
okay,
so that you can see, so that we can see how the integration of the R Studio to our data sets. Thank you very much.
Okay. Now, okay, let me show it to you. I will take you to where I have my directory on my system. Just follow me. Documents. I have okay, so data consults. I have R programming. Put it anywhere you are confident with. I have R programming class. Can you see? I have Unilorin users training. Open this. Can you now see? So this is where we are. Everything concerning Unilorin user training is there. You only need to create a folder. Know where the folder is. You now go to R Studio and come here. Pick a new project. Pick a new project. Okay. After you have picked a new project like that, you can see it's creating it. You see new directory. You see existing directory. If it's new directory you want to create, you just open it like this. New project. You can see my own link is here already. I've already created it. I don't need to create it again. But this is how to go about it. But assuming I want to pick existing, already you have created, the best thing is to go and create a folder. Know the name. So once you have known the name, you now come to new project. Come to new project. Come to existing. You can see, you now create project. Create it like this. It's going to be created for you. You understand? So everything in that particular direction will automatically come here. You see it by your side. Just like as if you are using VS Code. You know VS Code, when you're using VS Code, you have everything by your left-hand side. You have access to all the files in your directory. You just see as you are looking at it here. I hope I've cleared that.
Yeah, so, I think it's not still clear. So do you mean that because there are
hello,
some people
please,
that...
hello, please. Hello, Mr. Ismaila, please.
Hello,
there will be a time for question and answer.
This
please.
This is very, very important.
Please.
Hello, sir.
That's our rule, please. Our rule, please follow our rule, please. Please follow our rule. Thank you. Our rule is that we have time for question and answer. At that time, you can now ask the speaker what you want him to tell you. Thank you so much. Please abide with our rule. Thank you.
Notice down.
Dr. Please continue. Thank you so much.
All right. So the student, can see the data loaded here. Their names, their scores, everything like that. So you have access to it. Then you want to now see, okay, do you have any the part of the data that is missing? So check for missing values. So just put sum is.na. Is.na, the way we use it here is different from that of Python, it's different. So what you're going to do here, now you run it. If you have any of the data that have missing values. This one will reveal it and tell you how many. Run this. You can see 0. No missing value. Now, you want to check distribution of scores using box plot. When do we use box plot? Well, box plot is very, very good. It shows you if there's any outlier. If you have a, now it will tell you the first quarter, the second quarter, the median. It summarizes your data. I'm talking about continuous data. So you are familiar with it. I've used this. So let me just run it for you to see. You can see this is box plot. You can't use box plot for categorical data. It's for continuous data. Look at it. This, okay, can see. Now, what you see here, this is the 75th percentile, this is 25th percentile, the center is the median, which is 50th percentile. All these are the ranges, starting from like 40 something, and maximum is 100. You can see. Now, if you have any outlier, there'll be a point here. Point will be around this place. The point. So it's a very good method of visualizing our data. That's for continuous data, which I've done. Now, here, we want to see correlation. Correlation between score and study hours. Correlation. Correlation between study hours and score. Run. Can you see? The correlation here is 0.06. Very, very low. Very, very, very low. So now that is it. Now for to categorize data, now I said you can use all our packages to do many things. And for example, you are using this students data now. You want to get excellent students. You want to get good students. The one that need improvements. You want to do that. So look at what I do here. I bring the students data here. The mutate you see here, mutate means you want to create another variable. So the performance category, you now say performance category is another, this data does not have any performance category. It doesn't have any performance category. If you look at it, it doesn't have. No. The student data that we use up here, it doesn't have performance category. It doesn't have. You only study our score and all the rest. But now I want to create performance category. It will tell you whether you are excellent or you are good or you need improvement. So look at what I did. I now created it by saying performance category is equal to case when. Case when is a conditional statement. When you have score greater or equal to 85, I give you excellence. Now,
Okay.
you now say the remaining one, the other ones you have said excellent, you have said good. The remaining one, it means that it will be equal to need improvement. Anything below 70, you will need improvement. That's the meaning of this true. When you are true with you have satisfied every other condition. The last one, you don't need to write any condition. So you close the bracket. This one will give us. So let me run it. See what it's giving me. Now, the name, the score, up to the last one. So the score, 6 hours, study hours, performance needs improvements. Can see, I only show few students, 6 because they are 1,000. If it's 1,000, this is very good. When you are a lecturer in the class and you want people to see, students to see your advice for them. This comment, we can call this one remark. So the name for Zinab, look at Zinab now. Zinab score 61. Study hour is 14. Need improvement. Go and improve. 70, the person that scores 70, that's good. The one that scores 84, that's good. Other ones need improvement. So R is very powerful when it comes to data manipulation. To do a lot of things, Excel is good, but it can't come near R when it comes to data manipulation. Because you are in charge here, you are writing it. You understand? So summary statistics for that, for descriptive statistics of that, you have done that before, can rerun it for you. The histogram of scores now for data that's up to 1,000. The same thing, I've not changed anything there. It's only that it has increased the number. You are going to have this data now. See, that this is symmetrical. This symmetrical is look like dome shape. This is a dome shape or bell. This is a sign of normality. This is normally distributed. Why? Because I have so many of them. Data, data are many, the sample points are many here. That's why you have a very good data here. So that shows normality. It's one of the assumptions we use in analysis when it comes to regression. So visualization method is good also. So hypothesis testing. We have done it the other time on few data points. Now I'm going to use it for 1,000. Now we say it's 75. Let's run. The same thing. We are still not going to reject our H naught. We are not going to reject it. We are still saying, but the mean here, the other one was 81 or so. This one is 74 because we have a lot of samples here. That's all. So for the model, for linear regression, run it. So what we did at that time, we are now doing it for larger data. So this one, look at it. Study hour is a 0 point. This one is not totally significant. Just a point. You can see that's one of the powers of R is putting a dot here. This is almost going to like a borderline 0.05, and we are saying you reject H naught if your p-value is less than alpha. This one is 0.0 and alpha is 0.05. This one is 0.0565. That's why R is giving you a dot. Maybe for you to decide on your own, but to me, you are not going to reject H naught. This is not significant because this one is greater than 0.05. Because of this 0.56, you can approximate this one to it. So it's better if you're on safer side, you do not reject H naught. That is it. Do not reject H naught. So let's move over time. Now to sales. Now we have, the other time I just use now I'm using a lot of them. So let me run sales now for sales. For sales, okay, I'm still using a few for this. It's just a 500, 700. So look at how the sale will look like. Running is, let me explain this. Yes?
Please be rounding off. Thank you so much, sir.
All right. Okay. So let me quickly run all of this. Since you have the code, I'm going to send the code later. I'll give it to the organizers. You can see this is it. This is the date that's given it to you. So ANOVA itself is this. For ANOVA is this. Already, ANOVA is giving you this. This is degree of freedom. This is sum of square. This is mean for this. This is not significant also because the p-value is less, it's greater than 0.05. So now for sales, you can see the DPL I said you should install the other time. This one you can use your filter by sales electronics. Run all this to give you. So let me run this for you to see. You're going to have this. You can see electronics. It has categorized into clothing, electronics, furniture. So you can see them here. So let me now go to using Markdown. I'll just run this one once because everything we have done here is what I put here. The only difference is that we are using chunk here. The chunk is where you put your code. You can see. You can see they are in code. You can see them here. Then I put exercise there. Put all of this inside. So the beauty of this one is that I can run all of this once and you see the result coming out. Now, let me run this. Put HTML file. So you see the results, everything I've done, Markdown will give it to you in a single space. And that's the end. Let's see. So you can see everything we have done. I'll Markdown. You can see all of this, the results, the code followed by the results. The code followed by the results of T, of ANOVA, from Excel. You can see the box plot. You can see that of 1,000 samples. You can see the taste test, the regression. This is for time series, just for 5 points. This is what we have as the category. I've increased the category. Yeah, I have clothing, electronics, and furniture. Because we have this because I've used many rows again. That's 1,000. You can see the band. This is for regression. You can see this is confidence interval, the lower, the upper. then the line will best fit. Then for many of them, you have this. So you can take your decision. Thank you very much.
So, hello, thank you so much, Dr. Isaac, for your explanatory delivery today. We appreciate your time to have shared with us the preliminary and then the basic principles on the use of R. I'm sure our users have gained a lot. We open the floor for a little interaction now so that others that have questions can ask their question. Thank you, sir. So please put up your hand if you have questions, please. All right, so let's start with Ahmed Aremu. Can you go ahead with your question?
Yes, good afternoon, sir. And I thank our everyone presenter for a very good well lecture delivered. Sir, I don't know if it's very convenient or the package has the capacity to run structural equation modeling. Thank you, sir.
What? Structural equation modeling?
Yes, sir. Yes, sir.
Yeah, SEM.
Yes.
SEM, I've used it before, though presently only people are using SEM on her. A lot of people prefer using Smart PLS. But do you know Smart PLS?
Yes, I know Smart PLS, and that is what I'm acquainted with in running
Yes,
PLS.
yes.
It's not free,
R
so
will
I'm
be,
looking for an alternative package that
yes.
is free and
Aha.
user friendly. That's why I decided
R,
to ask.
yes, R is very, very good when it comes to structural equation modeling. I've used it before. Maybe you can call me later. I will send some things I've done using R on the structural equation modeling for you. And the path chart that's going to give to you. You know, PLS is not free. This one is free. So I'll show it to you. It's still doing it. But the only thing is that because you know people are running away from anything that is that will be writing code.
Yes, and sir, even the free part aspect of it that's meant for students, it can only accommodate 100 responses.
And that
so,
one, you can see it's limited. It's
so
limited.
and some of the output is not easy to copy, this and that. You know, it has to be through image. So it has so many limitations.
So many. So I advise people to look for way of using R for all of their analysis. Even these people that even the reviewer that we are sending a paper to review, they even prefer R and all this one we are using. They also want to learn. So it's good. We are using it.
Maybe I'll look for a way to contact so that I can get.
All right.
Thank you, sir.
You can see the organizer. They will put you through. Okay.
All right.
Yes.
All right.
Thank you, Dr. Isaac. I've also provided some links on the chat. You can check it to see if they're useful for your work. Thank you.
Yes. Okay. Thank you very much for that.
Okay. Daniel Idem, over to you. Thank you.
Okay, thank you very much. Good day, sir. That was a very insightful and wonderful session. I actually appreciated it. And sorry, I just want to ask, how would you recommend R programming for geospatial science?
Geospatial.
Science, yeah, map analysis and all of them.
R is excellent when it comes to geospatial. By God's grace, I've done that and I've written paper on that. Okay, let me quickly show you something here. I'll just run this. That one will answer your question now. Let me run this. I have spatial statistics using R. This is a recent thing I've just done. I'll just run this for you to see immediately. You can have rest of mind, though you will work, but it's good. It's a good work, and the work will be beneficial to you, and people are for whatever thing they want to do. The thing is that it's flexible, and you just sit down and write few code. Code will give you issue, but you will still get solution when you collaborate. So this one, you will see what I just did recently on geospatial. See, can see the date? Just this month. Can see? I can show it because it's not anybody's work. Now, look at map of Nigeria. Look at showing all of these points that I wanted to show. This is it. I can represent my values. I can do complex statistical analysis, econometrics. You know, we have spatial econometrics. You can do it. Get your model, spatial, geospatial model on this, representing all of this in population. This arm that has brought this for you, just code gave you this. You can see. You can see. So, you can see everything. You can see. These are things you can do. So I'm recommending it because that's your question. Recommending it is very good.
Right, thank you very much. I don't know if it will be possible if I'll be able to have a link so I can maybe interact further in this particular video because I'm
I see the organizer.
Yeah, I definitely do that. Thank you very much. I really appreciate that. Thank you.
Yeah, welcome.
Thank you, Dr. Isaac. I've also sent a link to you on a book called Geocomposition with R. You can also look at it.
Yes.
Okay. The next person, Samuel Lamidi. Over to you. Hi, Samuel. Are you there? Okay.
Okay. Okay. Thank you. Thank you for the what's called this insightful program. So I really appreciate. So my questions goes on like this. Under this, where you use what's called the chart, that is the bus plot.
Okay.
So you say we should use it for categorical variable. So if it is what's it called? You say we should use it for what's it called?
Continuous
Metric.
data.
Continuous data, that is metric. So if it is categorical what's called data, what are you going to use?
If it's categorical, you use, there are many again. You can use bar chart. Bar chart will give you, your x-axis will bear we have the categories, while your y will give you the values, the frequencies. So it depends. If you now have many categories, you use multiple bar charts or component bar charts. You understand? So because in that case, categorical, you are not looking for the mean. Yes. You want to see the category, you want to see how many. You understand? The categories. So that's how it is. You don't use a box plot for categorical data.
I think you've answered my question. Like my what's called question is even mainly if you have multiple level for the categories. I think you've answered to use multiple bar charts.
Yeah, multiple bar charts. Yes.
Thank you very much, sir.
You're welcome.
Okay, thank you. Gloria, over to you. Thank you so much.
All right, thank you very much, sir. Please, mine is not a question, but it's kind of a request. I don't know if this R script, the one you've used in teaching, if it can reach us so that we can use it in our practice.
Okay.
Thank you.
No problem.
Thank you, sir.
I will send it to the organizer. Organizer will distribute it.
All right. Thank you.
Yeah.
Okay. Thank you very much. Ayodele Oluwadare, over to you.
Okay. Good afternoon. My name is Ayodele Oluwadare. My question is, can we also have this kind of class next time, or I don't know the organizer's plan?
All right. Thank you so much, John. So this is a monthly program, right? So it's a meetup, and let me resend the meetup link again so that you can get the invitation anytime we schedule a meeting. So I have it on the chat now. So you only see everything, every event we schedule.
Thank you.
You're welcome. I don't know if Ahmed Arem still ask a question again. Hi, Arem. Okay. I don't know. Do we still have any question? Hi, Juliet. Okay, over to you. Thank you. Okay. Hi, Juliet. Over to you. Thank you so much.
Good afternoon.
Yeah.
Yeah, thank you. I just came in very late. I just came in very, very late. I didn't know, something happened and I couldn't come in. I wanted to know if there's a way to get training physically for such things as this, or this new, or this improved method of data analysis. Is there a way of having a physical training apart from online? Thank you.
Where are you physically located?
I am located in Lagos.
Where part of Lagos are you?
But I am actually very close to Unilag. I live very close to Unilag.
What we can do is to connect you with one of our data scientists in Lagos. If you want that, that means that you have to pay for one-on-one coaching. If that is what you want.
I will be very grateful if I'm giving a link to anybody so that I can do physical learning. It might make more sense to me to learn physically, because from there I might be able to know where I really need to begin with. I might not be at the level of so many other people, but I'm eager to learn.
Are you
And
specific
I also know
about
what I want.
or yeah, talking about something else? So that we'll know what to
I'm specific about R and other related methods of data analysis.
I'll drop my number in the chat box now. You can send a message on WhatsApp so that I will look for how to link you.
Thank you, sir.
Thank you.
Okay. Thank you, Dr. Sam. Okoro, over to you.
Okay, thank you, sir. You've just answered the question. If you drop your your phone number, I can contact you. I too need a physical training on it. I'm located in Abia State.
070 391 391 491
Juliet, please don't mention your number so that you will not be scammed. Okay, and the organizers will not be responsible for anything that happens to you. So I think Dr. Sam has put his number there, so you can chat him up. Thank you so much.
Yes, I saw the number. Thank you.
You're welcome. Then we have Perry. Hi, Perry. Over to you.
Good morning, everyone. I'm Perry good morning, everyone. I'm probably from Cameroon. So I came across the program while going through recent events on Meetup, and I saw that you were going to be hosting a space on data analysis for our. I am currently studying data analysis for Python. So when I saw the program on data analysis for R, I was really eager to know how it works and how I can relate from Python to R. And I can see that yes, the things that they do there they are similar. The interface, they are almost the same. So I wish to ask if you people have maybe a platform, let's say a social media platform where people can interact and discuss more on data analysis related concepts.
Yes, we do, and I've put the link on the chat. That's our meetup, so there could be many discussion on that page. So if you have any question, you can put it on the discussion page, and we'll be able to participate as well. Thank you. Alegbe. So I will just call for maybe I just pick two people randomly so that we can close this meeting as the time is going so much. Okay. Adeshola Alegbe, over to you. Thank you.
Yes. Good afternoon, sir. Thank you for the good work you are doing, and we really appreciate our presenter. It was a very good one. We really appreciate him. So, like Juliet requested, we that we are women in the field of statistics, we are really lacking behind. And let me say, in the area of not having a good mentor, somebody that will be able to put us through, tutor us, mentor us, and be able to let us know the to let offer the depth of data analysis. There's difference between being a classroom student and the difference between be able to lay your hand on data analysis as a woman and be able to excel in that area. So we are really lacking. I don't know how you can come in for us as our organizer to be able to link us with somebody who will be able to mentor us. Like I'm in Abuja and I'm a PhD student in Nasarawa State University.
Okay.
Yeah.
Thank you so much.
Sorry, I don't know. Let me make a comment.
Things that there are so many certificates we have acquired, but we should be able to lay our hand on data analysis and be able to represent statistics in every area of our endeavor. So I don't know, maybe you can link me up with somebody in Abuja too that can help me. Thank you.
Are you talking about Are you talking about physical training or mentorship or a community? Can you be specific, ma?
Yeah, the issue is that when you are talking about data analysis, either you are very good in R or you are very good in Python. And when issue of this online classes come up, you might not really have in-depth knowledge of what they do there because you have some people that are far gone ahead of you. But if there's a physical person, just like a physical class where you can have contact with, maybe on weekend, maybe on the 2 weeks basis, that can be able to groom you on data analysis or statistics. That is what I'm talking about, sir.
Okay. So the same thing I did, I also dropped my contact on the chat so that we
Okay.
can link you up with an R expert in your
In Abuja.
in Abuja
Yes, sir.
that you are going to be subscribed to
Yes.
learn personally. So
Okay,
you
sir.
can send a WhatsApp chat and mention that you are from this R user group. If you do not mention, I may not respond to the chat.
Okay. Thank you very much. I appreciate you, sir. Thank you.
Okay, thank you very much. The last but not the least is Solman Okoyemi. Over to you, please.
Sorry, thank you very much for this wonderful session. I'm a new person, I'm a beginner, so I don't quite know much about R, but at least I've been able to get one or two today. What I just want to ask is when we want to achieve at the end of the day is like giving a particular or a report on whatever code that we might have run. So when having your final report, maybe after you've exported your file, is it possible that all those codes that are showing, they are being removed and having a better interface for proper visualization of all the things you've carried out in R? Like, I don't really know. Is it like everything just comes like having codes, then the result in what you are going to print out at the end of the day?
Okay, Dr. Isaac, over to you, sir.
I just use that for you to know that it's possible. For example, when you run it now, that one is in HTML. You can run it in Word. When I run my code, my everything will come up. I'm doing this for students who want to confirm whether their code is bringing out result and they want to see the result. The way some people learn is that you teach them code and they see the result immediately after it so that they will learn it better. But when I'm running this for people, maybe PhD work of somebody now, I don't put code there, it's the result they're after. There's a way I can do it. At times, some people say they want to learn it. Some people they will say I should send the code. That's why I also want to see the code. You understand? So that's why I normally put the code for them. But if the person is not requesting for it, I remove the code. You get it? So, for example, now let me run the last one. Since it's the last question, I want to run this one in Word. So the one you saw is an HTML file, can be PDF. This is Word now. I can remove it, and even from here, where you see all of these, I've just changed it. Something's wrong. Okay, I've opened it before. Okay, no problem. But anyway, What if you have run it? Let me just run that of HTML for you. After you have done that, technically you can do it again, remove the code from it. But the reason why I normally put the code is what I've just told you. You understand? Some people they will say their guy want to see the code, whether it's right or wrong, things like that. That's why I put this. I think I've answered your question.
All right, thank you so much. That's just what I want to confirm. Thank you, sir.
Yes.
Thank you for the end of this session.
All right.
Okay. Thank you very much. Someone was asking if there's any WhatsApp group. We don't have any WhatsApp group yet, but we have the meetup group, because in Nigeria to actually manage WhatsApp group is very tough. You know, some people will be sending a lot of scam messages and many things that the admin won't be able to manage. But for now, so we have this meetup group, which is actually professional enough. So please, this is the group. So we think about the WhatsApp group. If the organizers approve this, then we can have a WhatsApp group. Otherwise, we have this one for now. This one, everybody that look at it, you can see your name, you can see your member, and you can actually put it in anywhere you want to use it for. I don't know. So that is it. Thank you. Okay, we will not be answering any question again. This is our time. So oh my God. Okay, and Dr. Isaac, should we call one person again? Chidi Olunkwa.
Okay, let it be the last person, please.
Okay, thank you very much. Okay, over to you, Chidi. Okay, I think it's a mistake.
It's a mistake.
So, okay, so thank you so much, Dr. Isaac. You actually did a 4-year course in statistics in just 2 hours. Right, thank you for teaching us all these wonderful things that R can do, from exploratory data analysis to modeling to data preparation and many more. So we really appreciate it. On behalf of our Unilorin user group, we say thank you so much. And on behalf of our participants, they're also saying thank you. Thank you and God bless you, sir.
I also say thank you for having me. God bless you.
You're welcome, sir. Thank you. Bye, everyone. See you next month. Bye.
Bye.
Yeah.